Greetings everyone. In this session, we are going to study the topic exponents. The topic will be divided into two sessions and this video is the first session of it. So let's get started. The mathematical definition of exponents says that it is the term consisting of base and power, where base is the number which is being multiplied by itself and power is the number of times it is being multiplied. For example, 3 to the power 6. Here 3 is the base number and 6 is the power. It means 3 is multiplied by itself 6 times. Similarly, minus 7 to the power 3. Here minus 7 is the base and 3 is the power. It means minus 7 is multiplied by itself 3 times. There are 8 laws in exponents. These laws are known as laws of indices or laws of exponents. So let us study these laws in detail. First law, x to the power m multiplied by x to the power n equals to x to the power m plus n. When base x to the power m is multiplied to the base x to the power n, the powers get added and gives x to the power m plus n. For example, 6 to the power 8 multiplied by 6 to the power 3 is equal to 6 to the power 8 plus 3, that is 6 to the power 11. When 6 to the power 8 is being multiplied by 6 to the power 3, we get 6 to the power 8 plus 3 and that is 6 to the power 11. Second law, x to the power m divided by x to the power n is equal to x to the power m minus n. When the base x to the power m is divided to the base x to the power n, the power gets subtracted and gives x to the power m minus n. For example, 11 raised to 7 divided by 11 to the power 4 is equal to 11 to the power 7 minus 4. When 11 to the power 7 is divided by 11 to the power 4, we get 11 to the power 7 minus 4, that is 11 to the power 3. Third law, x to the power m upon x to the power n is equal to 1 upon x to the power m minus n, where m is smaller than n. When the base x to the power m is divided by the base x to the power n, we can also write it as 1 upon x to the power m minus n. For example, if there is 4 to the power 4 upon 4 to the power 7, it can also be written as 1 upon 4 to the power 7 minus 4, that is equal to 1 upon 4 to the power 3. Fourth law, x to the power m whole to the power n is equal to x to the power m into n. When the base x consists of power m and the whole term consists of power n, then it can be written as x to the power m into n. For example, 2 by 11 to the power 3 whole to the power 5 can be written as 2 by 11 whole to the power 3 into 5, that is 2 by 11 to the power 15. Fifth law, x to the power minus m is equal to 1 upon x to the power m. When the base x consists of power minus m, then the term can be written as 1 upon x to the power m. For example, 9 to the power minus 4 can be written as 1 upon 9 to the power 4. For a fraction number, this law can also be explained as p by q whole to the power minus m is equal to q by p whole to the power m. For example, 7 by 5 whole to the power minus 2 can be written as 5 by 7 whole to the power 2. The fraction reciprocals and the negative power becomes positive. Sixth law, x to the power 0 is equal to 1. When a base x consists of power 0, it is equal to 1. For example, 19 to the power 0 is equal to 1. Seventh law, x into y whole to the power m is equal to x to the power m into y to the power m, and x by y whole to the power m is equal to x to the power m upon y to the power m. For example, 6 into 7 whole to the power 4 can be written as 6 to the power 4 into 7 to the power 4, and 3 by 8 whole to the power 9 can be written as 3 to the power 9 upon 8 to the power 9. Eighth law, if x to the power m is equal to x to the power n, then m is equal to n. For example, 15 to the power 11 is equal to 15 to the power q plus 1. Here we can write q plus 1 is equal to 11. So that's the end of session 1. In session 2, we will study the numericals related to exponents. So stay tuned and peace.